So, vertex form. How do I write something in vertex form? Y equals, what comes first? A, then, and, don't forget about that B, X, beautiful. This is vertex form of a quadratic. Who knows how I write standard? There it is. AX squared plus BX plus C. This is standard form. This is the one that you're most familiar with, I'm sure. Yeah, you've seen this quite a bit. So before we do our notes, which our notes are going over how to convert from standard into vertex, I'm quickly going to go over how to convert from vertex to standard because it's really simple. So first, we're going to convert from vertex to standard. I'm just going to show you really quickly. Let's come up with one. Y equals 2x plus 3 squared minus 5. What do you think I should do here to convert this into standard form?
You should distribute the squares.
So I should not distribute first because distribute is actually another form of what operation? Starts with an M. Multiplication. When you're distributing, you're actually multiplying. So in PEMDAS, what comes first? The parentheses. What is happening to these parentheses?
They're getting squared.
It's getting squared. So that's what I have to deal with first.
That's what I said. Distribute the square.
So you can't think of it like that. You're not actually distributing the square.
No.
You're not putting the square in, and this will be x squared plus 9. That's not how that works. No.
Don't you have to break it apart and you have to multiply by?
Yes. So this is x plus 3 squared. Another way to write x plus 3 squared is x plus 3 times x plus 3. So now I need to, it's called many things. FOIL, distribute, box method. I like to think of it as just distributing everything. Now, for now, I'm going to leave this 2 alone. I'm not going to distribute it yet. I'm just going to deal with my square first. So, x times x is how much? X times 3 is how much? 3 times x is how much? And 3 times 3 is how much? Beautiful. And I bring down the negative 5. And I combine like terms. What is 3x plus 3x? So now what do you think I'm going to do?
And then you distribute it.
Now I can distribute this 2. So 2x squared plus 12x plus 18 minus 5.
Combine my terms.
And I get.
Plus 3.
So that is how you go from vertex to standard. This is in vertex. This is in standard. Really, you maybe should have been able to figure this out without my help. This was Algebra 1. It's just, order of operations. What we're going to learn next, going from standard to vertex, is a little bit more complex. Ooh. So, in order to convert from standard form to vertex form, you have to do something that is called completing the square. So when you're trying to convert from standard to vertex, you have to complete the square. Now we're going to kind of skip this first part Last year we explored this using algebra tiles, and I really didn't think that that was very much worthwhile. So we're just going to skip this, the 1 through 4, yep. And we're going to go right to using the box method. Now I know you've used a box before in math. You used it when you're multiplying polynomials, right? Like x plus 2 times x plus 3. When you're multiplying those, you would use the box method. This is a little bit different. We're kind of working backwards here to figure out what term or what polynomial we can square to help us get this standard form. So what you do first, right here, we have this quadratic. Now, what's weird about this quadratic right here? It has a c. It doesn't have an n term. Now, this is for our benefit here. This is so that we can start off with an easy one. The first box, now I'm going to write what goes in each box. The first box is where you put your first term. So what is our first term in this quadratic? X squared. So here I'm going to put an x squared. And then in this box is where we put our bx divided by 2 term. So in this quadratic, which one is our b? Yeah, the 8. So this bx, how can we divide it by 2? What would it become? 4x, perfect. And same thing here. This is also going to be bx divided by 2 term. And bx divided by 2 is 4x, just like we had in the other square. So now, before we do this last box, let's figure out what is supposed to go on the outside of our box. Remember, when you did this multiplying polynomials, you would multiply things outside of your box. So you ask yourself, what times what would be x squared? Yeah, x times x would give us x squared. What's in that box right there? So now, what times x would give us 4x? 4. So a 4 goes right up here. And again, what times x would give us 4x? 4. What do you recognize here? You're multiplying, good.
So that's like if you did like x plus 4 squared, you probably get 8x.
Right. Okay. So here, on our top, we have the polynomial x plus 4. And on the side, we also have x plus 4. So we're multiplying x plus 4 times x plus 4 to get the stuff on the inside. Or x plus 4 squared. We'll get to that. Let's finish our box first. What do you think I'm going to write in this last box? 16. How did I get that? 4 by 4. Another way that I could term this is my b divided by 2 term squared. All right. So how could I rewrite this in standard form? Stop it. Right, x squared plus, what is, remember we have to combine like terms, so what's 4x plus 4x? Plus 16. So we just finished the standard form here. That's all we did. Now, how can this be converted into vertex form? So what does all of this, x squared plus 8x plus 16, where did we get those values? From inside the box that we got from multiplying what? Oh, so the stuff inside the box, if I'm working backwards, could have come from x plus 4 squared. And I have now converted this into vertex form. Do you see it? All right. I want you to try to do this next one right here. You guys try to do this next box. So, what is different about this one than the ones on the front? It has a third term. You start off the exact same way. You're looking at these first two values. That's what you're looking at first, right? Because that first term goes where in your box? Top left. We put an x squared. Then what goes here in the right box, right top? 4x, right? It's our b divided by 2x term. So this is 4x. And what about this bottom left? Same thing, b divided by 2x. And what numbers go up top now? X plus 4. And what about on the side? So what do we do to get that last box? Multiply 4 by 4. This is our b divided by 2 squared term. But what do you notice? It's different. It's different. So we did this box to figure out what could replace those first two terms, these first two that I underlined. Those first two terms are now going to be replaced with what's in our box. So tell me the values we have in our box. X squared plus 4, what is 4x and 4x combined? 8x plus, okay, that's what replaced my first two terms. What do I have after the first two terms? I still have a minus 6. Now, what did I add into the equation that was not there before? 16. And I know you guys all know that what you do to one side of the equation, what do you have to do? You have to do to the other side. So because we just added a 16 in, on the other side of the equal sign, I need to put a 16. This value that we're adding in here, this is what completes the square. This is why this is called completing the square. Because we're finding a value that completes our square. So now, what can we replace this x squared plus 8x plus 16 with? X plus 4 squared. And we still keep the minus 6 equals 16. Now what do you think I do? So I'm trying to get it into vertex form. This is the base of my vertex form, right? Having this x plus 4 squared. All vertex forms have that. Do I ever have constants on both sides of the equal sign? You need a y, right? I need to subtract the 16 over. So if I subtract 16 from 6, what do I get? Negative what? And I'm done. That's it. So if I wanted to write this in an equation format, the completing the square equation, I would maybe write this. We have our x plus b divided by 2 term squared plus the c that was in our original equation equals b over 2 squared. This is the completing the square equation. So you can either use the box method or you can just use that equation if you're good at memorizing equations, because am I going to give that to you on the test? No. All right. Do you or would you like me to do one more? You think you're set? All right. Go ahead and do 1, 2, 3, 4 on here. I'll leave this up so you can see everything that I did. And do 1, 2, 3, and 4. Y equals x plus your b divided by 2 term, which is 6 squared minus 35. So if you're confused on how to get that 35, we add the plus 1, and then what do we have to put on the other side? Right, your b divided by 2 squared term. So what is 6 squared? So to get it to the other side, what do? Subtract 36. And what is 1 minus 36? Negative 35. So that's where that answer came from. Are we doing okay? We'll do this third one. What do I start with? Perfect. Yep. Yes, and how did we get that 59 over 4? Right. So over here I had plus 15 equals 1/2 squared is 1/4. I subtracted 1/4 over. So what is 15 in terms of fourths? 60 fourths, right? All you have to do is multiply that 15 times 4. Well, 15 times 4 is 60. So 15 is the same thing as 60 over 4. So what is 60 minus 1? So it's just 59 fourths. And that's our answer. On fractions? So one more time. I had a 15, and then over here I have to put my b divided by 2 squared term. So 1/2 squared is 1/4. Subtract 1/4 over. Well, I can't add or subtract fractions without common denominators. So I have to get that 15 to have a common denominator with 4. 15 is the same thing as multiplying 4 times 15, which is 60, 60 fourths. So 60 fourths minus 1/4 is 59 fourths. Done. Does that make sense? All right. Last and final thing you must learn. It's not really that much harder. Well, I figured you could have got that one. This one is y equals x plus. Yes. Perfect. All right. So now, last thing. What is different about this problem? Oh, there is an A term. Anytime there's an A term, you need to pull that out of your first 2 terms. You don't really need to pull it out of this C term, just the first 2. So here, I'm going to pull a 2 out of x squared, and what am I left with? Yep. And pull a 2 out of 12, and I'm left with division, right? So 12 divided by 2 is?
Oh, divide that.
You're dividing, right? Because now I would have 2 distributed to x squared plus 6x. To distribute the 2 back in, it's multiplication. So to pull it out, I would divide. Minus 5. And then again, we're using these 2 terms to complete our square here. What goes in my first box? What goes over here in the right? And down here? And then what 2 polynomials am I multiplying? What goes up top? And, okay. And then 3 times 3 is 9. So, I can now replace those 2 terms that I underlined in yellow with what's inside the box. So, 2 times, what's inside the box? What's 3 plus 3? 6. I'm just combining these 2 yellow terms right here. 3x and 3x makes a... Good. And then what is the last thing I need to write? Plus 9. Minus 5. Now, because I added in that extra, which extra number did I add in? 9. However, on this side, did I actually only add 9? How much did I add? Why 18? Oh, because I have a 2 times 9, which is how much? So what do you think I need to add to the other side now? 18. What can I replace the numbers inside the box with here? Yeah, x plus 3 squared minus 5 equals 18. And what's my last and final step? Subtract 18 over. It just stays there. 2x plus 3 squared. And what's negative 5 minus 18? And I'm done. So this is what is called completing the square. When you have to convert from standard to vertex form, you have to complete the square. Any questions on any of this?